Welcome back to Voyager's Window. Today, we're starting something new, a deep dive into every planet in our solar system. Everything we know, everything that surprises us, and everything that still keeps scientists up at night. And we're starting with the big one, Jupiter. The largest, most massive, most dramatic planet in the solar system. The one ancient astronomers named after the ruler of the gods, not knowing just how fitting that name would turn out to be. So let's get into it. Everything we know about Jupiter. Before we can talk about what Jupiter is, we need to talk about how impossibly large it is. Jupiter has an equatorial diameter of roughly 143,000 kilometers. That's more than 11 times the diameter of Earth. If you could hollow Jupiter out and use it as a container, you could fit more than 1,300 Earths inside it. But size alone doesn't capture it. Mass is where Jupiter truly dominates. Jupiter is 318 times more massive than Earth. It is, in fact, more than twice as massive as all the other planets in the solar system combined. Saturn, Uranus, Neptune, Mars, Venus, Mercury, add them all up, double them, and Jupiter still has more mass. That level of gravitational dominance doesn't just affect Jupiter. It shapes the entire solar system around it. Jupiter's gravity has carved gaps in the asteroid belt, regions where its constant gravitational tugging has swept asteroids into unstable orbits. It acts as a kind of cosmic bouncer, flinging debris out of the inner solar system and, in some cases, potentially shielding Earth from comet impacts. Though it works both ways, Jupiter can also redirect comets toward us. It's complicated, as planetary physics tends to be. Here's where things get interesting. Jupiter is what we call a gas giant. But that label is a little misleading. The outer atmosphere is mostly hydrogen, around 90%, with helium making up most of the rest, plus small amounts of methane, ammonia, and other trace compounds. That part is gas. But as you go deeper, the pressure increases enormously. And at a certain depth, the hydrogen is compressed into a liquid. Not a gas, a liquid. This gives Jupiter something extraordinary. The largest ocean in the solar system. An ocean made not of water, but of liquid hydrogen. And it goes further still. Deeper down, the pressure becomes so extreme that electrons are essentially squeezed off hydrogen atoms, creating a state of matter that behaves like liquid metal. Liquid metallic hydrogen. This electrically conducting material, set spinning by Jupiter's rotation, acts like a giant dynamo, generating the most powerful planetary magnetic field in the solar system. Jupiter's magnetic field is between 16 and 54 times stronger than Earth's. Its magnetosphere, the region of space that field influences, extends up to 2 million kilometers toward the Sun and stretches behind the planet in a tail that reaches as far as Saturn's orbit. At the very center, there's likely a core. But Juno data has revealed it isn't the compact, solid core scientists expected. It appears to be diffuse and fuzzy, spread outward, possibly the result of a massive collision early in Jupiter's history that stirred everything up. Jupiter spins faster than any other planet in the solar system. One full rotation takes just under 10 hours. For a planet 11 times wider than Earth, that's a staggering speed. The equator is moving at roughly 43,000 kilometers per hour. That rapid spin is one of the key reasons Jupiter's atmosphere behaves the way it does. Those iconic bands of cloud you see in every image of Jupiter, they're the result of that rotation. The fast spin drags the atmosphere into parallel east-west jet streams, alternating bands of rising and falling gas, creating the distinctive striped pattern that's visible even through a small telescope. And within those bands, storms form. Constantly, relentlessly. The most famous storm in the solar system has a name: the Great Red Spot. It's an anticyclone, a rotating high-pressure system sitting in Jupiter's southern hemisphere. It's currently about 10,000 miles across, making it roughly 1.3 times wider than Earth. Winds at its outer edge consistently blow at over 200 miles per hour, with gusts reaching 400 miles per hour further out. We've been watching it for at least 150 years. And Juno data has shown us just how deep it goes. The storm's roots extend somewhere between 300 and 500 kilometers down into Jupiter's atmosphere. This isn't a surface feature. It's more like a weather system with foundations embedded in the planet itself. But here's something that might surprise you. The Great Red Spot is shrinking. Historical measurements from the late 1800s recorded it at around 25,500 miles across, wide enough to swallow 3 Earths with room to spare. When the Voyager probes flew past in 1979, it was still 14,500 miles wide. It has been contracting ever since and has accelerated noticeably since 2012. New research published in 2024 suggests it's being starved, fed by smaller storms that collide with and energize it. And as fewer of those feeder storms form, the spot is losing its fuel source. Interestingly, as it shrinks in width, it's growing taller and its color is deepening. It's not dying quietly. Whether it will stabilize at a new smaller size or eventually disappear altogether, nobody knows. But right now, we are watching one of the solar system's most iconic features change in real time. Jupiter doesn't just dominate the solar system with its mass. It has its own miniature solar system orbiting around it. As of 2026, Jupiter has 115 confirmed moons, more than any other planet we currently know of. But the story really comes down to 4. In 1610, Galileo Galilei looked at Jupiter through his telescope and noticed 4 small points of light that moved from night to night. He had discovered the first objects ever observed orbiting something other than the Earth or Sun. We call them the Galilean moons, Io, Europa, Ganymede, and Callisto. And each one is a world unto itself. Io is the most volcanically active body in the entire solar system. Its surface is covered in hundreds of active volcanoes, erupting constantly, painting the moon in vivid yellows, oranges, and reds from sulfur compounds. The reason? Io is caught in a gravitational tug-of-war between Jupiter and its neighboring moons. That constant pulling and flexing generates enormous internal heat. And that heat has to go somewhere. Ganymede is the largest moon in the solar system, larger than the planet Mercury. It's also the only moon known to have its own magnetic field. It's thought to have a subsurface saltwater ocean beneath its icy crust, making it another candidate in the search for habitable environments beyond Earth. Callisto is the outermost of the 4, heavily cratered, ancient, and geologically quiet, a contrast to its neighbors. And yet, even Callisto shows evidence of a possible subsurface ocean deep below its surface. And then there's Europa. Of all the places in the solar system where scientists think life might exist, Europa sits near the very top of the list. Beneath Europa's smooth, cracked, icy shell lies a global saltwater ocean. It's not a theory. The evidence is overwhelming and has been building since the Galileo spacecraft detected an induced magnetic field there in the 1990s. That kind of magnetic signal is the fingerprint of a conductive fluid layer beneath the surface. In other words, a salty, liquid ocean. And this ocean is thought to contain more water than all of Earth's oceans combined. What makes it so compelling isn't just the water. It's what the water is sitting on. The ocean floor appears to be rocky. And where liquid water meets rock with chemical gradients and heat, the conditions for life as we know it can emerge. We see it happen on Earth, in deep-sea hydrothermal vents, completely cut off from sunlight. Could something similar be happening on Europa? We don't know yet. But we sent something to find out. NASA's Europa Clipper launched in October 2024 and is currently making its way across the solar system. It will arrive at Jupiter in April 2030 and conduct nearly 50 close flybys of Europa, studying its ice shell, its ocean, its chemistry, and its geology. If there's life out there, even microbial life, Europa Clipper is our best current hope of finding evidence for it. Jupiter has been visited by 9 spacecrafts. Pioneer 10 and 11 made the first flybys in 1973 and 1974. Voyager 1 and 2 followed in 1979, returning the first detailed images and discovering that Jupiter has rings. Faint, dusty rings that are almost impossible to see from Earth, but definitely there. The Galileo spacecraft orbited Jupiter from 1995 to 2003, spending 8 years studying the planet and its moons up close before being deliberately crashed into Jupiter to avoid any risk of contaminating Europa. And then came Juno. Since arriving in 2016, it has fundamentally rewritten what we know about Jupiter's atmosphere, interior, and moons. Its extended mission has taken it on close flybys of Ganymede, Io, and Europa, and it's still operating as of 2026, continuing to send back groundbreaking data. Joining it soon will be ESA's JUICE, Jupiter Icy Moons Explorer, which launched in April 2023 and will arrive at Jupiter in 2031, where it will eventually enter orbit around Ganymede. Jupiter is busier with spacecrafts than it has ever been, and we are learning more with each passing year. Jupiter is a planet of extremes, the largest ocean in the solar system, made of hydrogen, the most powerful magnetic field of any planet, a storm that has raged for over a century and a half, more than 100 moons, and hidden beneath the ice of one of them, an ocean that might, just might, harbor life. We named it after the king of the gods. Turns out that wasn't far off. If you enjoyed this one, please do like and subscribe. It really does help the channel grow, and there's a lot more of this series to come. Thanks for watching Voyager's Window. Have a great day.